Okay, I'd like to take a little bit of time to go a little bit deeper into box plots. We kind of touched on them a couple weeks ago in statistics, but I really want to take some time to go a little deeper with these. So let's look at this first one, and it just says give the significance of this graphic. So when you look at a box plot, you really don't know what the specific numbers are. We don't know whether there's 50 data points or 500 data points, but all we know is a percent of data lives within each of these regions. So you can kind of see we have like a region right here, we have a region right here, we have a region right here, and we have a region right here. These are called quartiles because 25% of the data is within each of these boxes. Now this lowest number right here we call the minimum. This value right here we call the Q1 because that's about the 25% marker of this data set. This one is called the median. You guys are familiar with that. That's the midpoint of the data. This is Q3, which is again the 75% mark. And then we call this one the max out here. These numbers right here make up what we call the 5-number summary. So what this tells us is we know that about 25% of our data is located between 2 and 5.5. Similarly, we could say, okay, well, let's go all the way from here to here. We know between 5.5 and 15, this represents 75% of our data. So it's really giving us a sense of how much of the data is located between certain numbers. So one question you might ask yourself is, where is the data most packed together? Between which two numbers in our quartiles is the data most packed together? So when you look at this, we know that we can see that the range between these numbers, 2 and 5.5, that's a distance of about 3.5, right? This is between 5.5 and 7.5, that's a distance of about 2. From 7.5 to 11, whatever, that's a bigger distance, and so is this one. So this, between these two numbers, right here, this is going to be where the data is most kind of compact, or our data points are mostly closely related. Let's take a look at the next one. It says, is there something wrong with this box plot? So what we're really missing here is when you look at, let's say this one down here, you can see that it's got sometimes they call these whiskers, the lines that extend from the Q1 to the minimum, right? Well, is there something wrong with this box plot? No, there's not anything wrong with this box plot. All this means right here is that Q1 and the min are equal values, right? They're both 5, right? So if we have a data set that has a whole bunch of 5s, then it's possible that our minimum value and our Q1 value are the exact same. What that also tells us is that 25% of our numbers in this data set are going to be the number 5. That's another way to think about that. Then the last one I want to take a look at and see kind of how we can reason through box plots is, given the two box plots, which of the two data sets would have a larger standard deviation? Remember, standard deviation measures the spread of the data. So which one of these do you think has a larger standard deviation? Well, when we take a look at this, these numbers deviate between 1 and 10, right? So 100% of our numbers are between the numbers 1 and 10, right? But with this one, our numbers range between 1 and 18. So by looking at this graph, we can tell this data is more spread out, right? Our box plot is more spread out. So this one would definitely have a larger standard deviation.